Good morning. Happy Friday, and welcome to another installment of MBF Bioscience's new short-form webinar series called TJIF, or TJ's Information Friday, or TJI Friday, however you say it. Just thank you for joining me today, and I'm excited to bring you the final installment of the series for the year of 2020. This year has been obviously unlike anything anybody could have imagined, and I'm sure we're kind of all in the same boat. We're all excited for the start of a new year, the start of something new, and hopefully some change. So, with that being said, we're excited to keep this whole short form webinar series going in the new year, and we're hoping that as things progress, we're able to get more and more topics involved that you guys are all interested in. So I just want to again say thank you for attending today's webinar. If you don't know me, or if you haven't seen any of the other webinars, my name is TJ Tetreault. I work here at MBF Bioscience in our labs department. I do things from quality assurance to free trial and demo opportunities, and now obviously this webinar series. And like I said, we're excited to extend this into the new year of 2021. So again, thank you all for joining me in this final installment. At this point in the year, usually people are trying to finish up their experiments, or you're working toward generating some data or figures for grant proposals or funding, however you guys keep things moving. And so with today's webinar, I'll be focusing on, one, how to prepare your images to get the best possible screenshots and snapshots for your graphics, and secondly, how to generate movies. And the movies aren't necessarily tied to one program in particular, so this kind of extends into multiple programs that we have, whether you're on Neurolucida 360, Lucida 360, Stereo Investigator, NeuroInfo, or others. The movie availability is very helpful, and it's nice to be able to show off all the hard work that you've done. So before we continue, I just want to say that just like the other webinars, the success of today is dependent on your curiosity and the questions you have. So just like always, I'll move on, and we can talk about how to submit those questions. So you'll want to find that orange arrow in the GoToWebinar program. You'll want to extend that out and find the questions panel. Once you find that questions panel, simply type in the question, hit enter, and that'll come over to me. I'll do my best to answer them as fast as I can and as quickly as I can. If I don't see your question right away, I'm not ignoring you. I might just not have seen it, and I have set aside some time at the end of the webinar to answer any of the questions that might still remain. Lastly, the webinar is being recorded and will be available to view later, and we'll send a link to this recorded webinar in the email. So without further ado, let's get moving. The first thing that I want to go over is, let me just make sure that you guys can see that. It looks like you can. So the first thing that I want to go over, I'm going to make my 3D window a little bit larger, just to fit the full screen. And the first thing that I'm going to show is something that's kind of innate to Neurolucida 360 and to Neurolucida. Because these programs were designed to reconstruct neurons, neural processes, and so forth, this first feature, this post-processing, is only applicable to those. And so the reason that I want to show this is because it's really helpful for getting a nice picture that you can share with people, whether you want to brag about your work or you want to, look for some further funding. The first thing is, with this post-processing, there's 3 different options, and I'm going to deselect them all first and just kind of slowly build up to the grand top one here. But first, to smooth the tree branches, it's fairly simple. What I'll do is I'll zoom in closer to this soma so that you can see what I'm kind of talking about. When I hit apply options, the program is going to think for a second, but really what it's doing is it just kind of flickered. But here we're seeing that the edges are now rounded up a little bit. Everything has been smoothed out a little bit more so that we have a nice consistent figure that we can show. The next thing, and by the way, all of these checkboxes can be mixed and matched. So if you don't really need to see that smoothed out, you can always just ignore it. You can, like I said, mix and match as you please. The next is to smooth the soma. So I can, again, hit apply options. And we'll see that this soma, right now it's a little bit rough around the edges. We'll see that screen flash one more time. But now we can see that it's definitely much more smooth. It's a little bit more round. The edges and grooves aren't as deep and jagged. So that creates a nice mask. And the last thing here, although it looks like it's already applied, what I'm going to do is check off the smooth joins between soma and trees. And this is a question that we're asked a lot, or that I've been asked a lot during the demonstrations, is it doesn't appear that the branches are touching or connected to that soma. Is that an issue? And right off the bat, I would say that it's a very great thing that you've noticed. It's not an issue. That is a part of the program, to not have the soma joined directly to the branches, but that can be overcome for for a screenshot with this post-processing tool. So as I zoom in, we can see that all of the branches are now connected. The soma has been smoothed out, and now we have one homogeneous color for all of our neuron here. So what this is allowing us to do is we can take a nice pretty picture with this take a snapshot, and it's going to screenshot whatever is populated in this 3D window. So whether we have this single view, or if we wanted to do the quad view, I know that this is something that users like to see, is the different orientations of their data. And this is a nice way to show off, again, all the work that you've been doing. Once post-processing is done, if you leave and go back to any sort of editing or tracing, you'll notice that it kicks you out of that post-processing kind of viewport. We're not allowing that to be done over here anymore. And again, you'll see that the branches are no longer connected to the soma, and they've returned to their original colors. So the post-processing is strictly for visual purposes. It's not going to change the way that the data is being represented quantitatively. It's a qualitative measure that we take. Moving forward just a little bit, another thing that is important with getting the right data and kind of presenting it properly is ensuring that we have the right points at their origin. And what I mean by that is, if we go to points mode in the 3D window, I can select the point closest to the soma, and right here we can see that it says set point as origin. What that's saying is, in this data file as it exists, this specific point, which we would understand is the origin point, it's the closest one to the soma, so naturally that would be the start of the branch. What this button is saying is that this is not being reported as that starting point. So by clicking set point as origin, all we're doing is we're changing the structure of the tree. So when we go and do some terminal distances, we know that it's going to be working outward from the soma rather than potentially starting from a different position. It's important because if you're working with multiple cell bodies, what can happen sometimes is, as you're looking through, when we get to certain points, this one is already selected as the origin, so that's good. When we do the quantitative results, sometimes if you have a cell body that is closer to an origin point, it can recognize that improperly. So for example, if I had the origin point at the terminal end of this branch up here, let's say that this signal was considered a cell body. If this was the origin point, let me zoom in a little bit more. If this point was considered the origin and this cell body was generated, the results might change because it may think that this point belongs to this soma. And so that's where, if they're not connected, naturally they aren't in the program, that is. That's where things can get a little hairy and a little bit confusing. So it's always recommended, after you're done your tracing, to go through and make sure that, one, the origin points are in the right place, and two, that if they are in the wrong place, that they're switched over to the proper location. Um, there was a question here about the resolution of the screenshot, I believe. So when we're in that post-processing window, the resolution is fit to whatever the resolution of your screen is, and so whatever size the 3D window is. So if you have your three-dimensional environment, if you have that really small, it's going to be at this resolution versus if you have it on a large monitor and you have it full screen, that would be the resolution that it's taken at. Moving forward, the reason, well, half the reason that we're here is for the movie mode. This tool has been kind of worked through extensively by some of my colleagues, and it's a nice tool to be able to show again the data that you've acquired and the data that you've generated. So what we're doing here is we're going to create a movie script. So this is different from a lot of the other movie making programs that exist out there. So it's a nice time to kind of walk through how this is being done. Right now, as I rotate and zoom, we are in the movie mode, but none of these movements are being tracked. Nothing here is being recorded, and that's important to know. Right now, what we're doing is we're getting ready to set our start position. So I guess as I start to do this, I can explain how the movie mode works. So what I'm first going to do is I'll set my start position, and that is basically just how I want the image to be represented at the start. So I'm going to move it to the right and have it set at this orientation. When I hit set start position, the program is going to lock in this coordinate and this positioning of the traced data. And as I move my mouse, again, nothing's being recorded yet, but this is the next position that I want captured. So what that means is when I go down here, I can either hit set next position or click this icon to create a new clip. When I do that, it's going to generate a movement for us. So as I move my mouse along here, we can see that the program is going to automatically move from the starting position to the ending position, and it's going to know the fastest and most smooth way to transition from point A to point B. And that's essentially all that we're doing with this movie script, is we're moving, and we'll then move the 3D window again, hit the addition of the clip, and then we can go like this. And every time we click add the clip, it's going to set that new target location as the coordinate space that we're supposed to move into, and it will generate the movement from there. We as the user do not generate the movements. We just choose the location of how we want our data to be represented. The default is to move into 5-second increments, and that can be changed by simply dragging the endpoint of the clip. So here I'm going to slide these down, and I'm just going to make them all 4 seconds. So this can be pretty quick. The next thing that I'm going to do is I'm going to rotate and drag my image down, and I'll set this as the next position. And because this is all a demonstration, this is relatively unimportant, but 1, 2, 3, 4, 5. I'm going to zoom in and move to the furthest point from my soma and click once more, and I'll shrink this down. And then lastly, I'm going to move as if we were going to pan across our whole data, so that way we can see the full represented cell body here. So this is a 25-second clip that I've just generated from start to finish. And if I move my mouse and drag along with this green bar, we can see the movements that are going to be generated for my data file. And that all looks fine to me. So the next thing that we can do is we can kind of work through and edit some of the movements and how we want the data to be represented. By right-clicking on the clip itself, we can either delete it or we can customize it. In this case, I'll customize it. And the first option is to change the title. So if there's something that you're showing or something that is of interest, you can always change the title and say somatic movement or zoom on dendritic spine, anything like that to indicate to you, the user, that you're doing that sort of movement. The next is setting a color. If you want it to not be this purple color, we can always change that as well. And so this is a nice way to kind of visually distinguish the differences that are happening within the movie mode as you go. The last is the show tracing. So by taking that off, I'm going to do that on a couple here. By deselecting it, we can see that there's now that kind of classic no symbol, the circle with the line through it. So as I slide my cursor over once more, we can see once we hit that clip, it's going to remove the data and only show the image file. This can be used at your discretion, obviously, but it's a nice way to see the accuracy of your tracing and to see what is being represented from these beautiful images that you guys are taking toward the data that you're generating. So it's just a nice way to kind of work through and make a little bit more of an impressive movie. Another thing that we can do is if you were to right click in this sort of timeline up here at any point, let's go to the 16-second mark and I'll right click, we can add bookmarks as well. So this bookmark, you can see it's generated down here. It's also being brought up in this section here. And when we click on the bookmark section, it will bring us to that specific location in the timeline. We can also change the name of it if we were to double click. So I can call this the zoom, and that's going to be represented here as well. So from here, we can click and go directly to the zoom location. The very last thing that we would need to do, I'm just going to move my timeline to the end with this green slider, and I'm going to say end sequence. So that's just ending the movie kind of production, if you will. From here, we have a couple of different options. One is to save. So this is a little bit confusing to start, but it does start to make sense a little bit down the line. When you hit this floppy disk icon to save, what we're doing is we're saving this movie script. We're not saving the exact film yet. So if you have image data that's acquired in the same kind of pixel resolution, then you can save this script and keep it, and you can kind of translate it to the data as it moves along, or rather, different image stacks with the same resolution can follow this same script. So if you wanted to do a simple 360 without zooming in, you can save that as a script, and you can always apply that later by going to this open folder, the second icon. By going to the open folder, it's going to look for this XML script. And like I said, if you have the same resolution, the same kind of rotation and zoom will be applied to the image stack and data file. If the image stack or data file is a different sort of pixel resolution or dimensions, you can still work with the same script, but the results will vary. For instance, if you have a much smaller or much larger data file, the rotations might not move around the same axis point, and the zooming and panning might not make it through the entire stack. If it's large, if it's small, it might move the entire thing off the screen. So just be aware that the scripts are kind of useful for the same pixel dimensions and resolution. Lastly, the export button. This is how we move from the production to the final product of the movie. First, we'll choose the location that we'd like to save. This is the default, and I've already gone ahead and saved this MP4 for us. That is the standard and only file type that we can save at this point in time. The next thing is to choose the resolution. So what it's doing here is we're allowing you to choose whether you want to save it to the resolution of the 3D window or something more specific. We do allow these sort of high definition resolutions, and there's also less resolution if you're not in need of such high res data or movies. So just to give a quick glimpse of what that would look like, let me get that for you. I guess we can just run through right here. So essentially what it would look like is as we're rotating, it will go to our hidden, it will go through, and then it will continue to move along this way. And it will continue to do the movements. Let's see. Ooh, that's a great question. So Espen asked, is there any way to make a fly-through that was in quotations, in the dendritic tree. So that is a great question. With the way that the movie kind of automatic motion is going, I haven't had any success in doing a sort of fly through. And my guess, Espen, is that I might be incorrect in this interpretation, but my guess is what you mean is that if we were to zoom in, is it possible to kind of move through the tree in a way that we can kind of poke out on the other side and still kind of visualize it in that sense? The short answer there is no. That is something that we can look into. If there are kind of movements that you're expecting or looking for or are really desiring, that's something that we can look into for sure. The easiest way to kind of, I guess, make that sort of attempt at a fly through would be to start at the tip and move to the tail of this neuron specifically, while kind of keeping that same zoom level and maybe panning out at the end. But that is a fantastic question, and that is definitely something that we can look into. I believe I answered the formatting question, but yeah, the resolution is going to be saved to the dimensions that you specify. So whether it's the three-dimensional environment or that kind of HD resolution, and it's going to be in that MP4 format. Lastly, presenting data. This is obviously a huge component of research is being able to quantify results. We're not here just for pretty pictures and movies, as fun as it may be. So one of the more impressive things that we can do, and it might seem a little basic to some extent, but the shoal analysis is an extremely useful quantitative tool that we can use. And so I'll quickly show that here. It's important to note that the shoal analysis does require a soma. It's going to find that soma and use the centroid of it as the focal point and as the center of those kind of shoal rings as we build out. So it's of complete necessity that you have a soma in the created data. What we allow here in the shoal analysis is for the user to choose the starting radius and the radius increments. And so these don't necessarily have to match the starting radius, and these are all in microns, I believe. So the starting radius is just from that first ring that's being generated. The radius increments are all of the lines that go out from there. And then from here, we can choose the line thickness. So I'll do 2 just so it's a little bit more visually apparent. And I chose a nice yellow color. I really hope that shows up on this kind of dark screen for you guys. And then you get to choose the analyses that you like to run, what you want to be quantifying within those shoal rings. So as you can see, this is with our latest version. There is puncta available. So the puncta can be tied, when you're doing that detection, it can be tied to another object, such as a soma or a tree, or even a spine. Or it can just be kind of on its own. We don't necessarily need to do that detection within a distance. So here, I'll click display. And right away, we can see that we have our branch ordering here, which is fantastic. I'm going to shrink that down just a little bit so we can see that information on the screen. And I'll shrink down the shoal analysis result as well for those dendrites. So what we can see here, it might be a little bit difficult, and I apologize for that. But as I rotate and move my image, you'll notice that those shoal rings will stay kind of fixed to an extent. And that's because this is a three-dimensional tool. We're creating these rings almost as spheres that are building off of one another. And in that sense, we're able to generate the data there. So as we look through here, we can see specific spines and their specific types. If we were to have classified them, we'd be able to do that sort of quantitative analysis here. And to the same extent, we have the length of dendritic data within each ring, as well as the volume, the average diameter, nodes and endings, and so forth. So there's a lot of data that we can generate right from here. And it's really powerful data to kind of be able to present and move forward with. So that's always very exciting to be able to show people. And the nice thing about this as well is if you're working with data files that have multiple cells, this isn't restricted to one cell. In a couple of demonstrations that I've given, I guess privately, but with data that has multiple neurons, what we can do is you can choose the cell that you want to work with. Let me open up this trace structures tab. Up here, we can see that somas exist, so we can choose the specific soma. But a lot of times what's helpful is with our sets tool back in Neurolucida 360, if I bounce back, with sets, we're able to create different, cells that we can classify and kind of distinguish from one another. So from here, if we had multiple cells, we could choose to create a set with that. And then as we move our way into the Explorer program, there is an area, if sets are available, they would be available here. So you could just click on cell 1 or cell 52, whichever one you want, and you can run that Scholl analysis specifically on that. So it is a very powerful tool, and it's just a great way to be able to quickly generate data and show it off, and hopefully get some more funding for you guys as you are working. We're coming a little close to the end, so I'm going to hop back to this PowerPoint quickly. Whoops, let me get to the presentation portion. My apologies. So just wrapping up a little bit, I do want to thank Dr. Javier Di Felipe for letting us use that data file. It's absolutely beautiful. I also want to thank my colleagues, Julie McMullen and Alyssa Wilson. They helped a lot with the reconstruction of that. That was, I know, a painstaking process because of all the spines and the data that was there. So a huge shout out to them for putting up with that and not having the fast imaging engine that we do now. They had to do that back in the day when it wasn't as speedy, and it definitely wasn't as easy. So thank you to them. An upcoming event that I want to point out is there is a virtual international workshop on confocal microscopy and quantitative histology. This course is organized by Dr. Daniel Peterson, and he's an expert in confocal microscopy and stereology, and he is a phenomenal teacher. I did have the pleasure of meeting Dr. Peterson at SFN in Chicago last year, and he does a fantastic job. One thing that I personally enjoyed from just even going to his lecture was that he does a really great job of presenting difficult concepts in a way that, not oversimplifying them, but he talks about them in a way that makes them more digestible and manageable, so that you walk away feeling confident in the knowledge you've gained, rather than overwhelmed by just all the information that's available. So if this is something that you're interested in, this virtual international workshop on confocal microscopy and quantitative histology, that is going to be at the beginning of February. The dates are from the 1st to the 5th in 2021. And for more information or to sign up, please go to neurorenew.com. Again, this is a fantastic opportunity that I just wanted to make everyone aware of. And I know we're at the end of our time. One question that just came in is, do we have snow? We do. We didn't get quite as hit as the other areas in the Northeast. We probably have around anywhere from 4 to 5 inches here. Not quite like the feet of snow that are in other places, but it's beautiful. I do love Vermont when the snow is out, so it is a pleasure to have that up here once again. It makes the cold a little bit more bearable. And as always, I do want to thank you all for your attention and for your time today. Your questions, as always, they're very helpful. I love doing this. This is really fun for me to be able to do these short form webinars. So I do want to thank you guys as well. This has been a great addition to kind of my workload and what I do here. If there are topics that we have yet to talk about, or if there are touching points that you guys are interested in, please let us know in the short survey to come. We'll be sending this recorded webinar to you as well. But again, thank you all for joining for the last of this TJIF webinar in 2020. I'm really looking forward to the holiday season for a little break from all the madness, and I'm excited to join back with you guys in 2021. So thank you all again. enjoy your holiday season, and I hope you all stay safe and well. Thank you very much, and have a great weekend.